Ladies and gentlemen, boys and girls, my name is Subrata Sarker. I'm a mechanical engineer working in manufacturing industry more than 22 years. Today we'll be discussing on steel casting process. This is a manufacturing technology actually, and it's one of the oldest manufacturing technology, this casting process. Say by year, if you say it is 4000 BC, so from today it is more than 6000 years before this casting process was started actually. Casting is basically, pouring molten metal to a mold cavity, and after solidification of the material, it takes the shape of that cavity actually. This is a way of manufacturing some components. And if we, for example, say you all know in all cars there is an engine. So in engine block, and in industry also a lot of engines are there. Engine block is typically a casting components. There are a lot of components. It has got a, it is manufactured by casting actually in industry. And if we talk about the size limitations, like casting can be made from very tiny parts, say 10 millimeter size to a 10 meter size, and weight ranging from say 10 grams to 100 tons. Single piece is possible by different process of casting. And if we talk about the market size of the steel casting, I'm talking about only, there are other like non-ferrous metal castings are there. That is also a big market actually. If we talk about only the Asia Pacific market for the steel casting, it is around 80 billion US dollar actually in the last 2017 financial year closing. So it is a big market actually. And those many of us, like those who are into the engineering field and technical field, have visited these casting factories. But it looks very ugly actually in most of the casting factories, because process is such that it doesn't look sophisticated in most of the cases unless there is an automation or something is there. But behind this this manufacturing technology, there are a lot of high-tech expertise matters. There's software backups and expert activities are there. Nowadays a lot of softwares are available actually, like for designing of the different stages of the casting, like how the casting component geometry and dimensions will be designed actually. If you like to understand the simple way how the casting is happen actually, say you need to make a pipe like this, a special pipe which is not available in the market, so you would need to manufacture a small piece of pipe. So for making the casting process, you need to make a wooden or something metallic pipe which has got two half pieces, and inside of the pipe, which is hollow basically, for that you need to make a solid rod kind of things made of sand. And then you need to take two box which we call the core box, and put both half of the wooden pattern and make an ramp with, and then remove the pattern and make a hollow shape inside and pouring the metal, and after solidification you'll get a similar components like pipes actually. These are the typical components manufactured by in industry by casting process, different casting process. And if we talk about the sector-wise casting consumption in whole world actually, like in automotive sector, like car manufacturing sector, the total consumption of the casting is the highest, that is about 32% of the casting. In agriculture machineries consume 7% of the whole world casting process. Only for the different types of the engine, starting from the car and the industrial, the total consumption on the engine is 3% of the whole world casting. And railway sector, railway wagon manufacturing, railway engine, etc., altogether it consumes about 6% of the whole world casting. So if we talk about the process flow diagram, how the casting, steel casting happens actually, for making the casting, most important and first thing is you need a pattern. Pattern is something which some sort look to similar to the components which you want to make, but there are a lot of differences will be there. And then you make a mold. Mold means two half of the steel boxes where you need to create a cavity which you want to make. And some cases, depending on the component, if there is a hollow portion in your component, so there might be something which you made by the different special kind of the sand reinforcing the steel frame, which is called the core. So that is core. The pattern is made, then both core and pattern come together and make the mold. And then the mold is ready for pouring. Some opening is there in the mold, and a molten metal is poured on the mold. Then it got solidified. Then you break the mold and remove the solidified metal, then clean it and do the further processing. This is called pattern. The wooden pattern. It depends on, it is as close to the size of the component actually. And nowadays, earlier, say for last 50 years, this process was most of the cases in small industries. Like pattern making is a manual process actually, like manual skill, very skilled people, they manufacture this, design this, and they make this. But nowadays, a lot of CNC, computer numerical control machines are there, and it is you'll find in many part of India, also in most of the part of the Gujarat, you'll find that there are a lot of CNC machine by which most people make the pattern. And this is one of the these are the different types of the machine, and for that you need to 3D model of the component. And because this pattern is the most quality decider of the casting as far as the geometry and concern, metallurgical property of the concern. So if you can make the pattern very precisely through CNC manufacturing process, so your casting quality will be very, very fine actually. Because there are a lot of complications on the pattern, so by making manually it is very, very difficult to maintain all the dimensional accuracy. So it is better to choose the CNC control process for making the pattern. So this is one of the core actually, like where you don't need a material which is a hollow portion, that is basically the core. You can see the typically they say the angle pipe joints or elbow joints or something where you need a hollow in the pipes. So this is the core actually, the core of the casting. So this, and it is got break during the removal of the casting piece from the mold. So and if we this is basically the mold actually, two blocks of the two halves of the steel frame, and on which you put the two parts of your pattern, and then put the specially prepared sand, and then tighten it with the different tools, pneumatic tools or manually, and then the mold will be ready. This is called the mold box is ready. Now this hole, through this hole you can pour the molten metal, then it gets solidified, and the further casting process actually. This is typically the furnace of the steel melting induction furnace. And so when the melting is there are different way of controlling, checking that the melting is happened. Then from the furnace you take the mold in a different ladle, like heat resistance steel container, where you pour the molten metal on the container. That container will carry the these overhead cranes and pour on the mold cavity actually. So you can see here that from the furnace, from the furnace to this area of the mold is carrying by this container, and some cases when the weight of the casting is very big, and some system is there and for big mold, so it is normally mechanized way of handling this molten metal. And after solidification side, this will be the typical shape of a component, which there are a lot of things are projected which are not part of the component, but to make the process actually, like where the pouring, a lot of things are there, technicalities of the casting. So this is the looks actually when it come out after solidification from the mold cavity. And depending on the geometry, like there are a lot of different section of the geometry. So the solidification, when the molten metal starts solidifying, depending on the different wall thicknesses and a lot of other geometrical parameter, in every area solidification doesn't get uniform actually. In some area, you can see here in this picture, there is a software where you can find it actually. So where the solidification will be formed at last, and depending on some internal stress will be developed on the material actually when the casting is solidified, and there are software by which you can analyze how much get solidified. So according to you can make some corrections in the pattern or the geometry of the as-cast job, but still there will always be some stresses in the casting. Now after removal from the mold of the castings, there is another process which is stress relieving, is a heat treatment process, where you need to put the material on a furnace for a specified time period, and heating the material and then cooling depending on which rate, the normal cooling or the furnace cooling, then remove the material actually, so that the material will get a very optimum uniform strength throughout the structures. And after that you need to clean the material, grinding the material, cut to the extra projected portions. So this is basically called frettling or grinding process in casting. And after that, for fine dimensional accuracy, most of the cases the castings got to the machining process, by where the precisely material removal happens through different machine tools. And after that also there are a lot of testing process, whether casting is done very properly, So there is a ultrasonic flaw detecting techniques by which you can see whether there is any metallurgical deformation or defects inside the material. There are some dye penetration testing by spraying some chemicals. You'll find if there is a surface cracks on the material that can be easily visible. There is a hardness testing process. There is a magnetic particle testing process. So these are the 4 basic testing process of the casting, non-destructive testing process of the casting. And other than also some metallurgical, whether the metallurgical composition is achieved by this casting. For that there is a chemical analysis process like spectrography analysis, like this kind of testing process by which you can get the casting desired quality. So obviously there are some advantages of the casting process, like in a complex form or shapes or pattern which is very difficult to make by other alternative process like fabrications. So then casting is decided. Certain shape which cannot be machined by the different machine tools. So unlimited with the size and approach. So that is made by casting process. And like there are some many cases for design changes. It is easy to implement in the change in the pattern, and if there is a high volume is needed, so that is also casting is almost suitable actually. And large and heavy parts is a very some cases it is easier to take manufactured by the casting process other than the fabrication process, because a lot of distortion comes if the component is much bigger in the fabrication process. And there are some drawbacks is obviously there in casting process, like if the casting process is such that you are creating the material from the molten metal to solidify the material. So if there is something wrong in the process altogether, maybe some defects, the internal defects or porosity may come from the material, and material get rejected after doing so much of processing actually. Some cases there is a distortion or shrinkage actually happens in the casting. So you don't find that final required geometry job may got rejected. Some cases some impurities trapped inside the casting, and you find that by UT process or some testing process, but that is the process is over actually. Material may get rejected. Some cases where you need a very good surface finish, you will not get it through the casting process actually. Casting process got a limitation. By machining you may get this, and some cases making the castings is also very costly depending on a lot of parameters. Some alternative process by which you can get an optimum manufacturing cost. And nowadays the robotics and automation, like it is available in all process and induced getting. So you can see here in this picture, like molding is also made by the robotics, like it's and also the furnace, steel furnace handling when the molten metal is done actually. So how this door will be opening, furnace will be inclined to pouring the material on the ladle. So all these robotics handling systems are also available and is getting implemented in big and sophisticated steel casting factories. And if you talk about the business, future business of the steel casting, say for 2018 to 2022, as per the different, this projection, it is saying that the compounded annual growth rate for the steel casting for the next 4-5 years is close to around 2%. So if you find this presentation is interesting, you can share with your friends. And if you have not yet subscribed my YouTube channel, you can subscribe my YouTube channel by clicking on this bell icon so that you can get the notification for my future presentation. Thank you so much for your attention and time.